Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2238, in the Honda Odyssey models from 2011 to 2017 indicates an issue with the rear air-fuel AF sensor, specifically the IP circuit registering a low voltage. The AF sensor plays a crucial role in optimizing the vehicle's air-fuel mixture by providing real-time data to the Engine Control Module, ECM. This sensor helps ensure efficient combustion and reduced emissions. Its location is typically in the exhaust stream before the catalytic converter, allowing for accurate measurement of the exhaust gases. This issue could lead to poor engine performance, increased emissions, and may trigger warning lights on the dashboard. The troubleshooting process outlined will help diagnose and rectify the problem, ensuring the vehicle operates efficiently and complies with emission standards. The A-factor AF sensor, particularly sensor 1, located on bank 1 in the exhaust system, is pivotal in managing combustion efficiency and emission control. By measuring the ratio of air to fuel in real time, it informs the Engine Control Module, ECM, to make precise adjustments for optimal performance. This sensor is typically found in close proximity to the engine, directly in the exhaust system before the catalytic converter. Given its role, any malfunction such as a low voltage signal can disrupt combustion balance, potentially leading to increased pollutants being emitted. Additionally, the PCM, or Powertrain Control Module, processes the data from the A-factor sensor, making it essential for maintaining engine performance and compliance with federal emissions regulations. If there's low voltage on the circuit, it indicates a critical failure in the system that must be addressed promptly. The possible causes for the DTC P2238 include a short circuit within the wiring harness connected to the AF sensor. This fault could prevent accurate voltage readings from the sensor, leading to erroneous data being sent to the PCM. Additionally, poor connections or loose terminals at both the AF sensor and the PCM can introduce resistance, leading to voltage drops that trigger the low voltage fault. Lastly, a faulty AF sensor itself could result in it failing to generate the correct voltage under normal operating conditions. Each of these issues can independently or collectively contribute to the symptoms you observe, necessitating a thorough investigation of both the physical wiring and the components involved. Ensuring that each element in the circuit is functioning properly is critical for resolving the DTC. Typical symptoms associated with DTC P2238 include the illumination of the check engine light, which serves as a visual alert of underlying issues. Drivers may notice a degradation in engine performance, such as stalling, rough idling, or hesitation during acceleration. These symptoms stem from the engine's inability to effectively manage the air-fuel mixture due to faulty sensor data. In addition, owners may experience increased emissions, which not only impacts the environment, but may also lead to failing an emissions test. Lastly, decreased fuel efficiency is often a byproduct when the system is struggling to maintain optimal combustion, contributing to higher operational costs. Each of these symptoms provides valuable indications that there is a malfunction requiring attention. The first step in troubleshooting DTC P2238 is to turn the ignition switch to the on position, which powers the vehicle's electrical systems without starting the engine. After this, it's essential to clear the DTC using the Honda Diagnostic System, HDS, a specialized tool that can communicate with the vehicle's onboard computer. This clears any stored error codes and prepares the system for a fresh diagnostic evaluation. Following this, start the engine and hold the RPM at 3000 without load until the radiator fan activates, which usually indicates proper coolant temperature. This step ensures that the engine is operating at a level where it can provide accurate readings from the sensors. Finally, allow the engine to idle for 2 minutes to stabilize, preparing for the next round of diagnostics. Next, check for pending or confirmed DTCs using the Honda Diagnostic System. This step is critical as it allows you to determine whether DTC P2238 or the related P2241 for Bank 2 appears again after the previous steps. If either of these codes is present, it indicates that there is an ongoing issue with the A-THAFE sensor circuit that requires further attention. Conversely, if no codes are confirmed or pending, it may suggest an intermittent failure, meaning the system is functioning properly at that moment. In this case, inspecting for poor connections or loose terminals at the A-THAFE sensor and the powertrain control module, PCM, is advisable for potential hidden faults. Understanding exactly which codes are present provides actionable insights for the following steps in the troubleshooting process. For this step, turn the ignition switch to the lock position to ensure that all electronics are disabled, thus preventing any accidental short circuits while working on the system. Then, jump the SCS or Service Check Connector line with the HDS tool, which prepares the system for diagnostics. Jumping the SCS line provides the diagnostic tool access to critical data from the vehicle's computer, making it easier to diagnose issues accurately. Subsequently, disconnect the AF sensor, Sensor 1, by removing the 6P connector. This action isolates the sensor from the circuit for testing, allowing you to determine whether the sensor itself is causing the low voltage issue or if the problem lies elsewhere in the wiring or the PCM. Proper disconnection is vital for avoiding damage to the components while performing continuity tests in the next steps. In this step, disconnect the PCM connector B49P after the AF sensor has been removed. This action is necessary to isolate the PCM from the circuit for testing continuity. Using a multimeter, check for continuity between PCM connector terminal B31 or B32 and the vehicle's body ground, which is critical in diagnosing circuit integrity. Continuity testing confirms whether there is an unbroken electrically pathway between components, vital for proper sensor function. If continuity is present, it signifies that there is no open circuit. Therefore, repair of any short would be required between the PCM and the AF sensor. This will ensure that the electrical signal can flow correctly and that the sensor can perform as expected. If continuity is absent, it indicates a fault elsewhere, requiring further investigation. In the fifth step, reconnect the PCM connector B49P after testing for continuity. Once this is completed, start the engine again and hold the RPM at 3000 without load, just as previously performed. This step reestablishes the operational state of the AF sensor while allowing for new data collection. During this operation, measure the voltage between the AF sensor, Sensor 1, 6P, connector terminal number 5, and body ground using a multimeter. This measurement is crucial in determining the sensor's functionality and whether it is delivering the correct voltage signal to the PCM. If the voltage is within the specified parameters, it indicates that the sensor is functional and the issue may lie elsewhere. Conversely, if the voltage reading is low or absent, it points directly towards either a faulty AF sensor or further wire integrity issues that need addressing. After potential repairs have been made based on troubleshooting results, it's essential to run a final verification on the engine diagnostics. This involves starting the engine and monitoring it for any new DTCs while ensuring that the previous troubles, namely P2238, do not reappear. The Honda Diagnostic System, HDS, can provide real-time data indicating whether the repairs were successful. Monitoring sensor data closely ensures that the AF sensor operates within defined parameters, confirming both the integrity of the circuit and the sensor's functionality. Properly concluding with this verification step not only saves time and resources, but ensures that the vehicle operates efficiently without lingering issues. Should any codes appear or data display anomalies, further diagnostics would be warranted. Preventive maintenance is crucial for avoiding future reoccurrence of DTC P2238 and maintaining optimal engine performance. Regular inspections of the AF sensor connections can identify potential wear and tear before they result in a fault. Car owners should consider routine electrical checks of the AF sensor circuit, which can help detect abnormal voltage readings early on. It is wise to keep an eye on the vehicle for signs of performance decline or unusual burning smells from the exhaust. Keeping the electrical connections clean and secure can also stabilize performance and reduce risk of failures. Establishing these maintenance practices minimizes the chance of having to engage in more serious repairs down the line, enhancing the vehicle's longevity and reliability. In conclusion, understanding the implications of DTC P2238 is critical for maintaining the performance and efficiency of the Honda Odyssey from 2011 to 2017. Following a thorough, step-by-step troubleshooting process ensures that technicians can accurately diagnose the underlying issues without missing essential factors. The troubleshooting steps not only address the immediate code, but also promote long-term reliability by focusing on root causes. Additionally, incorporating routine maintenance checks will aid in preventing future occurrences of related DTCs, ensuring the vehicle continues to perform optimally. With proper diagnostic procedures and regular care, owners can protect their investment and guarantee that their vehicle remains within compliance of emission regulations. Please like and subscribe to the channel. See you next time.